Picture a chess grandmaster making the perfect move, a skydiver plummeting through clouds, a scientist peering into a microscope, and a flash of millions of neurons lighting up like fireworks. Imagine if every single neuron in your skull fired at once. If you could tap into the full power of your brain, what would you see? What could you do? Would you become a superhuman, a living computer? Or would your mind simply shut down? In the next 8 minutes, we'll bust the 10% myth, explore the science of brain capacity, and walk you through the wildest what-if scenario that scientists have ever imagined. The idea that we only use 10% of our brain first appeared in an early 20th century psychology lecture and has been repeated in movies ever since. It's a seductive story because it promises hidden potential waiting to be unlocked. But why does it matter whether the myth is true or not? Understanding how much of our brain we actually use tells us where the real limits lie and whether we can truly unlock hidden potential. Stick around and you'll learn 3 things. The real numbers behind brain activity, what happens when you push every circuit to the limit, and how you can boost your mental performance safely. First, let's set the record straight. Modern brain imaging, functional magnetic resonance imaging, positron emission tomography, electroencephalography, shows that nearly the whole organ lights up over the course of a normal day. Even the simplest tasks like breathing or walking involve multiple regions. The brain is never truly idle. It constantly monitors the body, processes sensory input, and maintains internal balances. So the 10% claim simply doesn't hold up under scientific scrutiny. Now that we know the myth is false, the real question becomes, what would happen if every neuron fired simultaneously? To answer that, we need to understand how the brain is organized. Think of the brain as a city divided into districts. The frontal lobe handles planning and decision-making. The parietal lobe processes spatial information. The occipital lobe translates light into images. The temporal lobe decodes sound and memory, and the cerebellum fine-tunes movement. Within these districts lie networks, like the default mode network that hums when we daydream, the salience network that decides what grabs our attention, and the executive control network that manages problem solving. These networks communicate through billions of synapses, creating a balance between activity and rest. Our brains are also remarkably plastic. When musicians practice for hours, their auditory and motor regions grow stronger, and athletes develop more efficient pathways for balance and coordination. This rewiring improves efficiency, not the amount of brain tissue we can use. So the idea of unlocking extra brain space is more about enhancing the speed and coordination of existing pathways. But firing every circuit at once would be like trying to run a city's power grid at full capacity without any regulation. Neurons are high-energy cells. Each spike consumes glucose and oxygen. The brain already uses about 20% of the body's energy, while accounting for only about 2% of its weight. If every neuron fired together, the metabolic demand would skyrocket, leading to a cascade of failures, heat buildup, loss of ion balance, and ultimately a shutdown to protect the tissue. In other words, the brain is designed to operate with carefully timed patterns, not a chaotic flood of simultaneous activity. What does this mean for the dream of superhuman abilities? It suggests that true enhancement comes from optimizing the timing and connectivity of networks, not from brute force activation. Training, sleep, nutrition, and mental challenges all help fine-tune those patterns, allowing us to push the boundaries of what we thought possible. If this is blowing your mind, hit that subscribe button and let's keep exploring together. If every single neuron were to fire at once, the result would be nothing short of a catastrophic overload. Imagine trying to turn on every light in a city without any dimmers or breakers. The wiring would melt, the transformers would fail, and the grid would collapse. In the brain, the equivalent of those breakers are the ion channels and metabolic safeguards that keep activity within survivable limits. When they are overwhelmed, the brain shuts down, often in the form of a seizure. That is why conditions such as epilepsy are characterized by sudden bursts of uncontrolled electrical activity that can temporarily incapacitate a person. The body's protective mechanisms are designed to prevent exactly what the myth of 100% brain use would entail. So, if a literal full brain blast is impossible and even dangerous, where does that leave the idea of unlocking hidden superpowers? The answer lies in the subtle art of fine-tuning the existing circuitry rather than flooding it with raw fire. Think of a symphony orchestra. Each instrument has a role, and the beauty emerges from the precise timing and harmony between them, not from every player blasting at maximum volume simultaneously. Likewise, our mental prowess grows when we improve the synchrony, efficiency, and flexibility of the networks that already exist. One of the most powerful ways to enhance that synchrony is through deliberate practice. When a pianist repeats a passage thousands of times, the brain allocates more resources to the motor and auditory regions involved, pruning unnecessary connections and strengthening the ones that matter. This process, called long-term potentiation, essentially makes the relevant pathways fire more reliably and with less effort. Over weeks and months, the same piece that once required conscious concentration becomes second nature, freeing up mental bandwidth for other tasks. Sleep is another non-negotiable pillar of optimal brain function. During deep sleep, the brain clears out metabolic waste products that accumulate during waking hours, and it consolidates memories by replaying patterns of activity. Without sufficient sleep, the neural networks become cluttered, and the capacity for focused attention and creative problem-solving drops dramatically. In other words, a well-rested brain operates much closer to its theoretical maximum than a sleep-deprived one, even though it never reaches a state of total activation. Nutrition also plays a crucial role. Glucose is the primary fuel for neurons, and a steady supply is essential for maintaining the delicate balance of excitation and inhibition. Diets rich in omega-3 fatty acids, antioxidants, and micronutrients support membrane fluidity, reduce oxidative stress, and promote the growth of new synapses. Conversely, excessive sugar spikes can lead to brief bursts of hyperactivity, followed by crashes, undermining the steady rhythm required for high-level cognition. Mindfulness and meditation have been shown to reshape the default mode network, the system that wanders when we are not focused on a task. Regular meditation practice can quiet that background chatter, allowing the executive control network to allocate resources more efficiently. Studies using brain imaging have documented increased thickness in regions associated with attention and emotional regulation among long-term meditators. This structural change translates into a clearer mental workspace, again moving us toward the optimal use of our existing neural real estate. If you're wondering how all of this translates into everyday performance, consider the simple habit of setting clear, chunked goals. By breaking a complex problem into smaller, manageable steps, you engage the prefrontal cortex in a structured manner, reducing the cognitive load on other regions. This strategy mirrors the brain's natural tendency to compartmentalize tasks, and it prevents the kind of overload that would otherwise trigger stress responses. All of these approaches share a common theme. They respect the brain's inherent architecture while nudging it toward greater efficiency. Rather than trying to force every neuron to fire at once, a strategy that would inevitably backfire, we work within the system's constraints, sharpening timing, strengthening connections, and providing the resources it needs to function at its best. So, what does this mean for the dream of becoming a superhuman? It means that the true superpower lies not in a mythical extra 10% of unused tissue, but in the disciplined habits that let us harness the full potential of the networks we already possess. By training our minds, honoring our bodies with sleep and nutrition, and cultivating mindfulness, we can push the boundaries of what we thought possible without courting disaster. Now that we've unpacked the science behind the myth and explored realistic pathways to mental enhancement, I'd love to hear from you. What habit are you most excited to adopt to boost your brain's performance? Have you tried any of the techniques mentioned? And what results did you notice? Drop your thoughts in the comments. The conversation helps all of us learn and grow together. If this deep dive sparked curiosity, consider sharing the video with friends who love a good brain teaser. And if you haven't already, give the channel a thumbs up and tap the notification bell so you won't miss future explorations into the wonders of the mind. Together, we'll keep peeling back the layers of what makes us uniquely human, one fascinating question at a time.